One more time, hello to all of you guys. I hope that you are doing great. Today is the last session for this current unit, ICT PRG 435. As discussed in the last few sessions, after finishing the basic Python programming, then in the second unit, we learn how we are able to use Python coding in different situations, specifically in IT and in cybersecurity. Also, we get familiar with a couple of more different things like how to import some libraries, how we are able to improve our functionality when we have and when we are using libraries in our Python coding. Also, in the previous session, we had a chat about software development lifecycle. We had a chat about pseudocode. We had a chat about user story, and we saw how we are able to improve our coding when we have those type of information. For example, when we start your coding with a user story, it helps us a lot to focus on what we want to achieve and what benefits we are looking by writing some codes. Pseudo also will help us to secure our codes as well. Later on, if you go to search for in cybersecurity, you get more information how we are able to improve our coding in order to have a more secure software. In the previous session, we had a chat about SDLC or Software Development Life Cycle. Usually, it's a start with planning, or it might start with a demand or a query or a request from a client. Firstly, we go to a planning step, then analyzing different types of information, designing the code, like for example, design using different tools, pseudo, user story, all of those things might be in these three steps. Then writing the code, testing the code, making sure the code is working with different type of inputs just to make sure that the code gives us the right output. And after testing and troubleshooting, then the code is ready to be deployed. And obviously, the last step in this process is maintenance and maybe retirement of the code. When we are writing the SDLC, there are different types of approach or methodologies. One of the first one was waterfall. It means that it's a systematic approach and it has heavy documentation. Planning is so important. It needs to go to a intense approval process. There is little room for changes. It's not flexible. And as discussed, it's mainly suitable for stable situations that they don't need to have a dramatic change in the software. Everything is already discussed, everything is already planned. For example, like ATM machines, they have a pretty systematic approach. Banking systems, they have a systematic approach. It's pretty rare that they have a significant change. And even if they want to have those type of changes, usually it goes to an intense approval procedure. Everything is clear, everything is documented, and then it goes and follow those 7 steps. In the other side, we have agile approach. So unlike the waterfall, it's more flexible, it gives more room for change. It's based on the continuous feedback. It breaks down a whole big project to multiple small pieces, and usually it goes through a short cycle of 1 to 4 weeks. Pretty easy to change, and software developing and delivery is pretty quick. There might be some other approach also somewhere in the middle, not too formal, not too rigid, and not too flexible, like V approach that might be sitting in the middle. In the previous session also, we had a brief chat about what is port, what is a server, what is a client. I gave you so many different examples like connecting to YouTube server or Spotify server, what happens in that process, how a browser or how an application on your iPhones or your iPads or your laptops may send a request to a server. Later on in our networking unit, we will see exactly what happens in this process. We will learn more about the binary. We will see how your request tends to binary, how it goes to your home Wi-Fi, through your Wi-Fi to your internet service provider, so many different routers probably on the way to get access to the destination. And then from destination, all data should put back in packages or packets in networking and sending back to come back to your device. In this process, server plays a very important role because that's a server which is responding to your queries. Servers, as discussed, are just usual PCs, but with a stronger hardware components because they are able and they should be able to work 24 hours a day, 365 days a year with no stops. So they should be reliable and they should be capable to handle huge amount of queries. Servers may run different types of services. We can use a server to help us to send and receive email. We may use a server to host our website. We may use a server for timing purposes. They may use a server for different purposes. As discussed, all of those services might be installed in one single device. If the business is not so big, it's not so complex, it's highly possible that multiple services to be run on one single device or in one single server. We call it, it's a general server. It means that it's running multiple services. But also, there might be one or more servers allocated to perform only one task, one special task. We call this type of servers a dedicated server, which is dedicated only to be an email server, to be dedicated only a web server. And I give you so many examples also to give you a bit of more idea about how a server works. Servers run different services on different port. A port was like a door. It was like a unit. It means when you are requesting for some type of services, those services are available in some specific ports. It means that something is listening on that port. When a query is coming through, that port is listening and that port is responding. For the security team, as discussed, it's very important to know which ports on a server might be open. As discussed, having more and more ports open, it means that there are more and more doors on a property. So it might be a little bit more challenging to secure that server. When there are more ports open, in cybersecurity, we say the attack surface is wider. So when there are more ports running on a server, it means that there is a wider attack surface and there is more chance of being attacked. Usually, in big companies, instead of having multiple services running on a server, they close all unnecessary ports and they only keep one or two door open to perform those type of services. And also they have so many security devices and protocols on the way just to protect those open ports. For the attacker team or for the attacker guys or bad guys, running a port scanning also is important because by running a port scan, they can see what type of port might be open. And as I showed you in the previous class, each port may have some type of vulnerabilities. So it's just like knocking each door to make sure if there is something at the back or not. Just knocking the door to see if someone is responding. This is the task of a port scanner. There are technically over 65,000 ports. Not all of them are in use, and we don't want to go and scan all of them. But there are some famous popular ports like port 80, 443, 21, 22, 20, 353. They are common ports, and it's highly possible that the attacker they are looking to see if those type of ports might be open, and if yes, they try their chance. There might be some security procedures, some security devices to protect those ports, or they might be not. So as you see, both security team and the cyber criminals, they may look for port scanner and they use it just to detect what type of port might be open. So technically, when you want to reach to a server, not only you need to know the IP address or the address of that device, but also we need to know which port we need to connect in order to communicate with that type of service. So here there is an example of an IP address. Again, in our networking unit, we go through to IP addressing and IPv4, not IPv6. IPv6, we will learn it in Cert 4, but in Cert 3, we will learn about IP version 4 and how it works, learning about octets and how to convert binary to IP, how many IPs do we have in this version and how it works. At this stage, for simplicity, we just take it as given. And IP version 4, it has 4 blocks of numbers that they separated by a dot. And that's the way that we can find any device in our internet. So a port is like a door or a unit in a server that programs use to communicate. Remote access, it uses port 3389. SSH, which is a port type of encrypted remote connection, it uses port number 22. File is using port 21 and DNS is using port 53 and etc. So how it works, the attacker sends a request to each of those ports and based on the responses that they get, they can analyze it. Again, in Cert for in cybersecurity, we go more in depth to this process. For example, we will see how we are able to send different types of packets. And we will do that in practice. We send TCP packets, we send full TCP packet, half TCP packet, we send UDP packets, we send XMAX packets, And different types of packets may generate a response. Based on the response, we get some information, what type of services might be running on that port. And when we know those information, then we can find the right tool and equipments to attack those ports. So technically, port scanning is the first step for malicious servers or also for the security team. This is the first step. It's just like data collection. And then based on the data, we can analyze. For the security team, they can analyze on how to secure and protect the systems. For the bad guys, they can analyze what type of tools or equipments they can use in order to attack those ports. So this is the first step, or reconnaissance, as I mentioned in the previous session in our cybersecurity procedure. Also, we had a chat about the firewalls. Firewalls, as discussed, are some security devices that we may use in our network. It might be a software or it might be also a hardware. So you can go and purchase a firewall, or it might be a software that you can download it. Or sometimes if you are, for example, using Windows, it's already installed, you can go and configure it. So it's just like a wall that you can put it around your services, you can put it around your network. But also firewall, they need to have some rules to allow which type of traffic is allowed to come in and which type of traffics are able to go out. Again, port scanning is useful to make sure that our firewall's configuration is appropriate or not. Again, in for in cybersecurity, we have some units, like for example, we will learn about pfSense is a very famous firewall. Then we will see how we are able to go and change the rules and how we are able to create some new rules, how we are able to modify rules if the firewall configuration is appropriate or not. That's the kind of topic that we have in cybersecurity courses. For port scanning, there are so many already available tools like Nmap or Moscon or Zmap or Zmap that they are available for use. But what we want to achieve in this unit, we want to write our own codes, something pretty similar to Nmap. In the previous session, if you remember, I show you how to use a command inside the Kali Linux, which was Nmap, putting an IP address of a target, and also it shows how many open ports might be available in that target. And also, as I showed you in the previous session, when you know which port is open, it should be pretty easy to just do a quick Google search and see what type of vulnerabilities might be available in that open port. It doesn't mean that all open ports are vulnerable. Obviously, a server needs to communicate. You can just imagine a server is just like a shop. So there is always chance of having some shoplifters. If you want to get the chance of having a shoplifter to zero, it means that you need to close the store. Then the risk is zero. So obviously, anytime the store is open, there might be this type of cases having shoplifters or stealing something from the shop. But what we can do and what usually the stores they do in reality, for example, in busy time or if they are selling expensive items, or for example, for some expensive sections, they may have some security standing and controlling and checking. They may use CCTV cameras, they may use alarming gates and etc. So the same thing for a server. When the server is up and running, there is always the chance of being attacked. There is always the chance of being impacted or affected by a virus, by different types of cyber attacks. So technically, we cannot and we don't want to stop our operation. It should be up and running, but it doesn't mean that if any open port is always vulnerable. No, all servers, they are working, they have open ports, but it might be there is this possibility that an open port may have some vulnerabilities. But obviously, all servers have and run open ports. Okay, so that's everything we had in the previous session. But I want to do now, uh, just to show you the last step in this port scanner, and then you definitely should be able to work in your assessment task too. Let me share my screen and have a look in our Google Colab. So let's to have another look back to our assessment task 2. Mm, assessment tasks. And let's have a look on assessment task 2. So if I go back again to the assessment task 2 and to the case study scenario, it says that you're a junior programmer working for a network security company, DG Core, and your team is developing a tool to scan open ports on devices in a network. This tool has some advantage like identifying the potential vulnerabilities and enhancing the security posture. The project manager has assigned you to design, code, and test this port scanner script. Firstly, it's asking you to identify and summarize the script requirements. So now you have heaps of knowledge to do this. Document the expected benefits, features, and a script's overall functionality, a description of user interface, command line output, and all of those things. Creating a pseudocode. So we have a very comprehensive chat about what is pseudocode and how to create a pseudocode and a flowchart. For the flowchart, it's up to you if you want to use Canva, if you want to use Microsoft Word. I'm happy even if you use a paper and a pen to just write down your flowcharts and um, mention a step by step what you need to do. And it's a debugging process, a list of test cases, and etc. Okay, let's go and do this. So I go to our view, collaborate. There might be so many different types of answer for this task. You can use different libraries, you can use different codings. I don't want to say the code that I'm writing here is the best one, and I don't want to say that's the only answer or potential answer for this question. No, if your coding is working and if you're explaining and able to explain how it works, that's totally fine. It's just here to help you to get some idea on how to do this task. The question asks you to firstly, I have this assessment on my another screen. So firstly, it's asking you to start with some comments. So you know when you want to change a line to a comment, you need to put a hash. Firstly, it's asking for the file name. So for the file name, you can say it's a port scanner. Then it's asking to put down your name and the purpose and the date. So you can do that as well. Again, with a hash. So you can put your name. Just put your name here. Then the purpose. The purpose of this code is to scan open ports, to scan a range of ports. Date, you can put today date if you wish. Today is the 20th of 11. So they are all our comments. In order to write the code, as discussed in the previous session, you just need to import. And what I did, I imported socket. You can import any other library. You can import Escape, you can import Nmap. It's all up to you. And if you remember, I show you also how to get more information about socket. You can just go and search it in Python documentation and get familiar with some basic commands. So I just leave this for you. You see there's some information for you. For example, it says that if you're running an IP version 6, it says for AF INET 6 address family, a 4-tuple host, port, blah, blah, blah is used. All of those information are here. And I just have like 2 or 3 line of code that it might be not familiar for you. Cool. So firstly, I need to import socket. What we want to do, firstly, we want to ask for a target IP. Then we need to ask for the starting port and ending port. So pretty easy. We just need to create 3 variables. So target, there is an input, enter IP address or host name, just to get what IP address you want to scan. Later on, you will see that it's possible also to scan a range of IPs, not only one single device. I want to scan a whole network. Imagine in VicUni, there might be 1500, 2500 PCs, servers, IoT devices, and I want to scan all of those devices. So in that case, I need to go and scan a whole subnet or the whole network. Sometimes when we are using some tools like Nmap, it may take ages. It's pretty slow, specifically if you're using Nmap and you want to scan a whole network. It takes too much time, sometimes a few hours. If you want to go and scan thousands of ports on 1200 PCs in a campus, it takes a couple of days. It's not a very fast scanner, but it provides too much information. It's a slow, but too much in depth. We have some other scanning tools that they are very fast and but they provide just a very little of data. So it depends which one you want to use. Maybe you say, okay, it's better to use the one that it's a scan pretty slow, but it provides too much information. But later on, instead for cybersecurity, you will see some of those scanners, they might be quickly detected with the security system. Imagine that if I'm a hacker and I try go check every single IP, I might be detected. It's just like that you have a stranger coming to your property. Imagine it's an apartment and they just go and knock all the doors. So it's pretty strange. Eventually someone will see them and probably they can call police and say, look, we have someone in this property. They are knocking all the doors. It's the same things in a network. If someone is trying to go and scan an IP after another IP, an IP, another after IP, the security team and the security devices, they get suspected. And they can block that IP or they can quarantine it or anything else. So usually an attacker or a penetration tester, if you want to be in the penetration testing carriers, not only they need to be precise, also they try to be hidden. They don't want to get detected quickly. So this one, it's asked for the target IP. I need to create another variable for a starting port. So a code like this, a start port, enter the start port, end port, enter the end port. For example, I want to start scanning from port 15 to 200, from port 1 to port 100, from port 1 to number 1800. It's up to you. Okay, so technically I did nothing. I just have only three variables. Then you see you have a 4. It says for port in range, a start port and end port. What happens here? So it's a loop. As I showed you yesterday, it's a start with the first port, it check it. If there is a response, it show it. If there is no response, it goes to the next port. So it's a loop. You remember when we used 4, we had the range. If I go back and show you a couple of examples that we worked before, functions. Yeah, here you see that, for example, we have 4 for I in range 12. It means that go and print attempt number, and in each iteration print 1, 2, 3, 4, 5 up to 11. Okay, so that's one of the previous examples that we had in our class using for and for loops. So pretty the same here. We don't specify the beginning and ending of our range. We just say it depends to a starting port and ending port. Imagine if I tell you I want to start from port 1 up to port 100. So you know that this doesn't include the last one. So if I leave it like this for port in range start port to end port, and I say from 1 to 100, it doesn't include 100. So if you want to include 100, you can put plus 1 here as well. So for port in range, so if I say my starting port is 1, from 1, and my ending port is 100, it means go and start scanning from port 1 up to 101. But it doesn't include 101. So I technically just scan 1 to 100. When I press enter, you see that it automatically suggests you. It says, for example, for S, you can change it to another variable name if you want. I can put it sock just to make sure how it works. So why we name this socket? Because it works like a socket. Imagine that there are 100 sockets on the wall, and you just want to make sure if there is electricity in each of those sockets. Imagine that you have a plug, and for example, that plug is connected to a device like a light, or I don't know, something like a heater, portable heater. So you have a socket. You just go and plug it to each socket to make sure if the heater is working or if the light turns on. So then you know that there is power in that socket. It's pretty the same, but it's a virtual socket or it's a virtual plug. It goes and create plugs in the background. So here you say socket AFEN8. It means that just go and check the IP version 4. If you go back to this library here, it gives you all of those information. Here, as you see, it says AF underline INET address family, where the host is an string representing a host name in internet domain, like something, or an IPv4 address. All the other things, you just need to go and find it here. For example, a stream and etc. That's a typical command when we are using socket. So just create a socket. I name it sock. Again, it's a variable. Also, we need to set a time. So we can say sock set timeout. There are only these two line of code that might be pretty new for you. And I say only wait for 1 second. Because sometimes when the scanners, they scan a range of ports, they may wait for a few seconds to see if there is any response or not. And it may take time. So here in set timeout, I say just wait for 1 second. Knock the door, wait for 1 second. If there is no response, go to the next one. Knock the next door, wait for 1 second. If there is no response, go to the next one. Or if there is a response, just list it for me. So I set a time. The other things that I can do, I can say then put the results in this result variable. You see that again, Google Colab automatically suggests me the line. If the connection is up, if there is a connection, then put the target IP and the port in the results. And if result is 0, just print that port is open. And if it's not 0, just print the port is closed. That's it. That's the whole code for this port scanner. So how it works? Firstly, it's import socket. Then it asks for an IP address. Then it asks for a starting port. It asks for the ending port. It creates a loop to go and repeat this process again and again and again. So the beauty of this task is in this two line, and obviously it's in this library. If we wanted to write this code without the help of socket library, probably we needed to have 100 line of code. But socket has everything. By creating this line of code, it quickly go and plug to each socket to make sure if there is connectivity or not. And you see, we have only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 line of code, and you will see that it will work. Again, if you want to add another text editor, or if you want to, for example, save the data and save the results in a TXT file. In the previous sessions, we had a chat about file handling. So you know how to create a file, how to append the file, and also how to save it, and how to get access to the file by clicking on this file icon here in your Google Colab. So it seems that everything is fine. If you are asking about fstring, that might be new for you. That's totally fine. If you want to get rid of fstring, instead you can say string, put an string, and say port, which is this port, is open. Or you can just use fstring. Fstring means to directly insert a variable into your string. So it seems that everything is fine. Let's see if our code is working. So this first four line, they hash. So Python will skip them. Then it will go and import socket. Then it will ask for your IP address, the starting port and ending port. Let's run the code. As you see, it's asking for an IP. I'll just put a random IP. That's the private IP. And as I explained in the previous session, when we are running our code in Google Colab, because we are running this code in Google servers, it doesn't have access to your private IP. This is a private IP that I have. We just want to see if the code is working. That's fine. So I press enter. Then it's asked, what is your starting port? I say just go and start from port number 1. Then it's asked for ending port. So now it's running this code, this line, ending port, and I have int to convert the string to an integer and all the other things. So when I press enter, you see that it's the start scanning the ports and it will go to port 100. So it's a loop. It goes to the first port, try to plug onto that socket to check if there is response. If there is response, to print it's open. If there is no response, to print the port is closed. And the reason, as I mentioned yesterday, it's pretty obvious because I'm testing over a private IP. If you run it over a public IP, possible that it works, but we don't want to do that. We just want to see our code is working. Instead of running over a public IP, I go and show how to do this in my local IDE, like VS Code, or if even you want to run it inside Python terminal, that's totally fine. 97, 98, 99, and 100. Okay, so it shows that your code is working. Again, as I said, if you want to insert text editor to save the auto in the text, that's totally fine. So just keep this. If I now go back to what we did in the previous session, and I run the Kali, and I run this Metasploit machine as well. You remember when I run this port scanner over Metasploitable, it showed some open ports like port 21, 22, 53. Let's just show you again, and then what I do, I will use exactly the same code, but instead I give it the IP address of my Metasploit machine to see if it shows those open ports or not. Okay, so I'm running on IP.20.67 and map 192, 168.20.67. You see, it's pretty quick and it shows some open ports very quickly. Open, 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 open. And it doesn't show the closed ports. It just says that 978 ports in close. And you definitely know port 1 up to 20, they closed. 24 is closed, 26 up to 80, they closed, and just like that. So it was pretty quick. It went and scanned 1,000 ports in just less than a second, in 0.63 second. Okay, so what I want to do, so that's your code. Technically, this is the code that you need to use. Um, This is the code. Pretty easy, just importing the socket, creating three variables using a loop. If you want to change this to a function, pretty easy to do that. It's not needed, but if you want to do that, it's pretty easy. You know that you should say def, then give it a name like this, port scanner column, and then what you need to do, you just need to send all of your codes one space back to the right if you need it. If not, that's totally fine, just to leave it as it is. So that's the code for this task. What I do now, I run it over my VS Code. So I copy exactly the same code and I go to VS Code. So I already installed Python just to show you it works on the local Python as well. File, new file, and I name it port, save it on desktop, create the file, and I save the code here. Oh, I forgot to save it as a Python code, so I just go, it's exactly the same code that I had in Google Colab. I go and save it, save as port scanner, and save it as Python code. Save it on my desktop, save. So you see port scanner is here. Sorry. Okay, then my code is in my desktop. So I just go desktop and I want to run this port scanner .py, as you see, port scanner.py. So I go back to my VS Code and I say Python 3. That's the code that you need to use. So Python 3 port scanner.py. Then it's asking for the IP address. So this time I just give the IP address of this vulnerable machine, which is 192.168.20.67, exactly the same IP that I use it in my Kali machine. So I say it's 192.168.20.67. Then it's asking for the start port 1, the end port 100. And then you see that it found port 21 is open, 23 is open, 22 is open, 25 is open. I'm expecting to have port 53 and 80 also to be open. 53 is open. 80 also should be open. Yes, as expected. And that's it. So instead of saying just go up to port 100, if you say go up to port 1000, it shows it shows exactly the same result as we had here in our Kali search. You see, we had port 21, 22, 23, 25, and 80. 1, 2, 3, 4, 5 ports. And we got exactly the same result by running in a local Python. You see that we have port 21, 22, 23, 25 also is open, and port 80 also, as you see. It correctly shows that port is also open. Also, yesterday, I reckon it was Jake asked how we are able to scan our own device. So if you want to scan your own device, pretty similar. What you need to do, you can go to command prompt. If you're using Windows, in Windows, just type ipconfig. In Windows command prompt, just type ipconfig. And then it says, what is your IP? So I'm running on this IP. If you run it in your own PC, you should have a similar IP starting with 190 to 168, but the other two numbers might be different. So I'm running 192, 168.56.1. That 56.1 is my current PC. So let's do go and run the scanner again. 192, 168 dot 56.1 dot 56.1. I want to start from 1 and go up to 100. So it shows exactly the open ports on my PC, on my local computer. So you see port 21, 23, 25, which was open in that vulnerable computer. Now it's open on my PC. Okay, so it seems that all ports are closed on my computer, which is fine. And lastly, the last things that I want to show you, in my board, I show you the firewall. And as I said, sometimes the security team, they use port scanner to check the firewall configuration just to make sure the firewall rules are okay, or if you want to test. Sometimes they might be some ports left open for some reason, misconfiguration, or just being ignored or skipped. So if you just go into your computer and type firewall, Windows Defender Firewall with advanced security. So later on in Cert for Cybersecurity, you learn more about these features. But just to briefly show you, you see here we have inbound rules and we have outbound rules. Let me to make it full screen. The firewall, as discussed, is just like a security guard. Here, as you see, there are some services, and also here you see there are some ports. You see port 7000, any port 80443, for example, here you can see, which is using for HTTP. There might be some other ports like 68, like 546. Just like that, what we can do, we can create some open ports, we can create some closed ports, we can create some new rules to allow a port or to block a port, and plus so many other features and functions that we have in a Windows firewall. We will learn more about this firewall later in our other units. But you see that my code is working both inside VS Code, as you see, or if you go to Google Column, it's pretty easy. If you want to expand and add some more extra features, that's totally up to you. But that's the core code. Cool. Any question? Let me have a look on the chat. For scanning 8888, no, it shouldn't be any problem. So 8888 is the Google DNS, and it's a pretty strong website. No, there should be no issue. They will not catch you, so don't worry. But that's your code. If there is, let me to pause